discussing about the protection of carbonyl group, and in this chapter we have discussed about the acyclic ketals and acetals, and then the cyclic acetals and ketals. Finally, today we will discuss about dithioketals and dithioacetals as protecting group or carbonyl group. We will discuss both cyclic and acyclic dithioketals and dithioacetals today. The course is a role of protecting group in organic synthesis, and my name is Dr. Tahir Makbul. First of all, the objectives of today's lecture. We will discuss about the introduction, key features, installation, removal, and examples of cyclic and acyclic dithioketals and acetals as protecting group for carbonyl group. So first of all, the advantage, why we use dithioketals and dithioacetal instead of simple ketals or acetal. Basically it is expansion in the methodology to increase the flexibility of the protecting group, because आपको पता है सिंथेसिस के अंदर नई से नई चीज़ें आती रहती हैं जो मीट न्यू challenges while you are doing organic synthesis. So in order to meet those challenges, we need to expand our methodology, and we will try different strategies in this regard. So instead of using simple ketals or acetals, you can also use dithioketals and dithioacetals, because both of these groups will afford more flexibility. Now, both cyclic and acyclic analogues are known just like simple ketals and acetals, but cyclic dithioketals and dithioacetals are more common. Reason is very simple, because the acyclic derivatives are easy formed and hydrolyzed much more readily than their cyclic counterpart. यानी कि एसाइक्लिक बड़ी आसानी से बन भी जाते हैं, लेकिन डिसएडवांटेज क्या है कि उतनी आसानी से दीज आर बीइंग हाइड्रोलाइज. सो ज़्यादातर कॉमनली आपको साइक्लिक dithioketals ही मिलेंगे लिटरेचर के अंदर. इसका मतलब ये नहीं कि ये साइक्लिक रिपोर्टेड नहीं है, लेकिन ज़्यादा एग्जांपल्स आपको उन्हीं की मिलेंगी. यहाँ पे उनके की फीचर्स देख लेते हैं. फर्स्ट ऑफ ऑल, देयर स्टेबिलिटी टू एसिड इज़ द मेन फीचर. अगर आप कंपेयर करें सिंपल एसिटाल या कीटाल से, वहाँ पे हमने pH रेंज जो देखी थी, दैट इज़ 4 to 12 in most of the cases. So these are stable between pH 1 to 12. So their stability to acid is their main feature or main flexibility over simple ketols or acetals. These are also stable to most of the oxidizing agent except the chromium oxide. These are also stable to nucleophiles. Similarly, these are insensitive to hydrides, organometallic reagents. However, these are sensitive to mercuric and silver salts, examples of Lewis acids. With remaining Lewis acids, these are relatively unreactive. Here is the general common procedure for their installation. We subject the carbonyl compounds to react with thiol or merceptan, which is being used in two equivalents in the presence of HCl or BF3 as an acid. So we will get dithioketal or dithioacetal as a protected carbonyl group. As far as removal or cleavage is concerned, the dithioacetal or dithioketal, that is acyclic, is treated with mercuric chloride under aqueous conditions to get the carbonyl compound back. Here are some examples. You see in this example there are two ketones, 5-membered and 6-membered. So this 6-membered ring is selectively protected by using dithioketal. Diethyl ether is used as a solvent in a course of 2 hours, room temperature, 93% yield. अब यहाँ पे रीज़न अगर आप देखें तो आप रिंग साइज़ का डिफरेंस भी देख सकते हैं कि इसकी रिएक्टिविटी हो सकता है ज़्यादा हो. एंड सेकेंडली आप यहाँ पे देखें तो दिस कीटो ग्रुप इज़ इन क्लोज विसिनिटीज ऑफ दिस, सो दिस मे बी स्टेरिकली क्राउडेड, दैट्स वाई दिस कीटो ग्रुप इज़ मोर एक्टिव. सो यहाँ पे सिलेक्टिव प्रोटेक्शन हुई है 6-membered कीटो ग्रुप की अगर आप इसकी फर्दर डिटेल्स देखना चाहें तो ये 2 रेफरेंसेस हैं जिनके अंदर देख सकते हैं। यहाँ पे ये भी फॉर्मेशन की एक एग्जांपल है जिसके अंदर हमने डाइफिनाइल थाइन यूज़ की है। उसके अंदर हमारे पास ये टर्मिनल फार्माइल ग्रुप है जिसको प्रोटेक्ट किया गया है बाई ट्राइफिनाइल फास्फीन. The yield is more than 83%. If you want to know the further details, you can see the reference number paper and get the details. Here is another example. यहाँ पे cleavage basically है हमारे पास जो dithioketals है इसको cleave किया गया है by using silver nitrate, silver oxide, acetonitrile water at 0 degree centigrade in 85% yield. So basically this is an example of cleavage of dithioketals. You can see this reference or further details in Tetrahedron letter volume 1885 and 1977. So here is an example of formation and cleavage of SS diacetyl acetal or ketals. Here in this example this farmyl group is protected by using 6 normal H2SO4 at 25 degrees Celsius, 84% yield, and you get this protected farmyl group, that is acetal dithioacetal. And similarly this dithioacetal is deprotected by using sodium methoxide in methanol 25 degrees Celsius, 40 hour, 96% yield, and the product is recovered by using chloroform in water as a catalyst or silica. So the farmyl group was lost during attempted protection with ethylene glycol and tosylic acid. यानी कि they have also tried ethylene glycol in order to form the cyclic acetal, but they have lost the farmyl group during the protection. For further reading and application of these acyclic dithioketals and dithioacetals, you can visit the page 477 and onward in green protective groups in organic synthesis. We come on to the cyclic dithioketals and dithioacetals. First of all, we will discuss the key feature. The stability is almost similar to their acyclic analogues. These are relatively insensitive to acids. This stable between pH 1 to 12, which is quite similar to that of acyclic dithioketals and dithioacetals. These are also stable to many oxidizing agents, nucleophiles, hydrides, organometallic reagents. These are sensitive to mercuric salt, and strong lever acids like AlCl3 is used to deproduct or cleavage. Installation method is just similar like cyclic ketals and acetals. There we use 1,2-diol or 1,3-diol. Here we use 1,2-ethane dithiol or 1,3-propane dithiol. The acid catalyst is BF3, boron trifluoride ethtrate. So if you treat with 1,2-ethane dithiol, you get 1,2-dithiolane, that is cyclic dithiacetal or ketal. Similarly, if you treat the carbonyl compound with 1,3-propane dithiol, you will get 1,3-dithiolane. This is the 5-membered ring containing 2 sulfur atoms, and this will be the 6-membered ring containing 2 sulfur atoms. As far as removal or cleavage is concerned, the most common method is to treat the 1,3-dithiene or dithiolane with mercuric salt. You will get your original carbonyl compounds wax. There are many other reagents which you can apply and you can see in the literature. And the first one is boron trifluoride ethtrate in aqueous THF containing mercuric oxide. Alternatively, you can use N-bromosuccinamide. You can also use iodine in dimethyl sulfoxide. You can use ceric ammonium nitrate. We will also discuss one of the example. Iodomethine in aqueous media. You can also use N-chlorosuccinamide and silver nitrate in aqueous acetonitrile. So if you can see, mercuric salt is the most common reagent which is used to cleave the cyclic dithioketal or dithioacetal. In addition, there are many reagents which are mentioned here. So here is the first example, which has been taken from the drought synthesis of 1,1-hydroxy jacinone. 11-hydroxy jacinone. So here the 120. Here the diketone 120 was converted to monodithiolane derivatives, that is 121. This one. As you know, there are two ketonic groups are available. So this keto group is selectively converted into dithioketal, that is monodithiolane 121 by using these conditions, like DCM, to get the compound 121, that is monodithiolane derivative. 7 steps were required to transform 121 to 122. This is the synthetic manipulation, and finally the treatment with silver nitrate in hot ethanol, that is 65 degrees Celsius, regenerated the ketone unit 123 in the which was protected in 120. So this is the example which has been taken from the drought synthesis of 11-hydroxy jacinone. There are some other examples which I have mentioned. Here is the first one. In the keto group, two carbonyl groups are present here, the carbonyl group and the ketonic group. Ketonic group is relatively naked, and it has been selectively protected as dithioketal by using 1,3-dithiol and boron trifluoride ethylate. If you want to see the detailed reference, you can go to this paper. There is an other examples in which this keto group is protected by using the 1,2-dithiene in dichloromethane. Using this reagent, the yield is 85%, and you get the 5-membered cyclic dithioketal. These are the references. Here is the example of formation, that is dithioacetal. In this case, 1,3-dithiol is used in order to get this acetal, that is 6-membered. Here they use lithium chloride diethyl ether, room temperature, and the product yield is 90%. Here is the reference if you want to see the complete paper. So this method is the cleavage of the dithiene. Here this compound was treated with silver nitrate in ethanol and water, 50 degrees Celsius, 20 minutes, 55% yield, and you get the ketone back. This method is based basically on the oxidation. Here is another example. यहाँ पे हमारे पास अगर आप गौर करें तो दो ग्रुप्स हैं जो कि प्रोटेक्टेड हैं, लेकिन सिलेक्टिवली जो है ना, ये ग्रुप जो है वो डी प्रोटेक्ट किया गया है. बेसिकली दिस इज़ selective cleavage of this alpha beta unsaturated thioketals. This is done by using 3 equivalent titanium nitrate in methanol, THF, and 0 degrees Celsius. And the yield is 67%. So these conditions have been used to affect the selective cleavage of alpha beta unsaturated thioketal. Here is the reference if you want to see the complete paper. Here is another example of the cleavage. Dithiolane ring is cleavage during hydroboration, where this compound is treated with borane in THF, hydrogen peroxide, and sodium hydroxide in ethanol in order to get the target compound in 85% yield. Here is the reference. इस एग्जांपल में बेसिकली डाइथाइन रिंग है, उसको ब्रेक किया गया इन ऑर्डर टू गेट द कीटोन बैक। यहाँ पे सीरियम अमोनियम सेरिक अमोनियम नाइट्रेट यूज़ किया गया है इन एसीटोनाइट्राइल एंड वाटर रूम टेम्परेचर। आप देखें रिएक्शन टाइम इज ओनली 3 मिनट्स एंड यू गेट 50% यील्ड। बट इसका डिसएडवांटेज क्या है, ओवर ऑक्सीडेशन हो गई है, यहाँ पे पहले डबल बॉन्ड नहीं था। So both of these hydrogen has been removed under these condition in order to protect this ketonic group. So this method has resulted in over oxidation to give an enone. Here is the reference. So for further reading and application, page number 442 you can visit. You will get a number of examples regarding the cyclic dithioketals and dithioacetals for your knowledge. So I think it is sufficient as far as production of carbonyl group. We have discussed in detail about various acyclic ketals and acetyls, cyclic acetals and ketals. Similarly, we have discussed acyclic dithioketals and acetyl, and finally cyclic dithioketals and dithioacetals as protecting group for carbonyl group. So in next lecture we will start some न्यू टॉपिक। तब तक के लिए अल्लाह हाफिज़।